Alright, number 11, we want to change the log expression to its equivalent exponential expression. So remember, when going from log to exponential, this problem is log base b of 49 equals 2 to the third. All you do is you take the base and now it is raised to that power. So 49 equals b to the 2/3 power. So that's the exponential expression we want to look for. So A or B don't look satisfying. Looks like B to the 2/3 equals 49. Uh, 12, we want to know for the given functions f and g. F times g, we want to state the domain. Okay, so the rule was, whenever you do functions, you had f plus g, f minus g, and f times g. All of these will have the same domain, and that is whatever the domain of f and g are individually. You look at the overlap, you kind of stack them. So f would have a domain of all real. It's a linear equation. There's no fractions in 4x plus 6, no square roots, no logarithms. So your domain would be negative infinity to positive infinity. So if you had a number line, if you had a number line, it would be the whole thing, okay, the whole number line. And then the same thing for g. Okay, so g has no fractions, no square roots, no logarithms. So again, its domain is negative infinity to positive. So again, it would be the whole number line. So if you were to match those up, the part that they have in common is everything. They have everything in common. So the domain and range of f plus g, f minus g, and f times g would be negative infinity to positive infinity, okay, which is all real numbers. Now, we also want to find f times g, so we're going to actually multiply these two functions together. So that would be 4x plus 6 times 5x plus 2. And we will FOIL this out. So I would do 4x and 5x. That would give me 20x squared. 4x times 2 would give me 8. 6 times 5 would give me 30. So 8 plus 30 would give me 38x. And then 6 times 2 would give me 12. So this is a function 20x squared plus 38 plus 12. 20x squared plus 38. I don't see that. Did I make a mistake here? Oh, it's a minus 2. Okay, it's a minus 2, my bad. Minus 2. So let's go back and do that again. That would still give us 24. That would give us minus 8, positive 30. So that should give us 22x. 22 here. So 20x squared plus 22. I'm going to be careful with writing it. And then there will be a negative 12. So 6 times negative 2 would give us a negative 12. Got to be careful writing the signs down. So A looks like that's what we want, all real numbers, and that will be the equation. We're going to use the graph to answer the questions. We're going to find the numbers, if any, which f has a local maximum. What are the local maximums? Okay, so this graph goes up without bounds, so it goes to infinity. Those do not count as maximum. So you get a maximum when you have a high point and then it goes back down. So like this here. So this graph has a local max, a high point in between this area. It happens when x is 0 and the y value is 2. So it has a local maximum at x equals 0, and that is 2. So that's what we do. You read the location according to the x-axis and the value according to the y. Alright, 14, we want to use the graph of the one-to-one function to sketch the graph of the inverse. So kind of hard to see all of it here. This is bigger. So we have this image. We're going to flip it across the line y equals x. Basically, you're going to be changing the order pairs. The x and y are going to interchange. So instead of 1, 4, I would have 4, 1. And if I look at these options, C is the only one that gives me the 4, 1. That would be the mirror image of flipping this graph across, and will give us our inverse.